The Indian Association of Structural Engineers, also known as I-Struct-E, was conceptualized and constituted in the year 2000 by a group of senior professional structural engineers from all over the country. I-Struct-E is registered under the Society's Registration Act 21 of 1860. I-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, I-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar. As its president, I-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, I-Struct-E has collaboration with various international professional like-minded associations and institutions. I-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. I-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. I-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. I-Struct-E's activities are widely appreciated and known for quality technical contents. I-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. I-Struct-E's publications are becoming popular with time. I-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, I-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. I-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. I-Struct-E has its student chapters in several leading engineering institutions as well. Membership of I-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about I-Struct-E is available on its website www.iastructe.co.in.
Vikas, should we start?
Yes, ma'am.
Yeah. Hello, everyone. A warm welcome to once again to one of our webinars on post-install Anchorage to concrete. Okay. As you have just seen the video of I-Struct-E, which mentions about the activities, what we do as an organization. Okay. Our prime objective, as you have seen in the video, that is to provide a platform to our fellow engineers, fellow structural engineers especially, so that they can disseminate the knowledge they have, they can gain the knowledge which is inherent for the latest use of the technologies and the skills required. Okay, not only we cater to the fellow engineers, our other objective is also to handhold our budding engineers through our student chapters. Okay, so we have various student chapters at different universities and colleges, which cater to the budding engineers by providing them the required skills to enhance their career in the structural engineering. And especially we provide a platform where they interact with the fellow practicing engineers and learn how to bridge the gap between what they study and what is being implemented in the field. Okay, and and one more important announcement I wanted to make, that we are going to organize a national conference on futuristic structural engineering, as you could see on the slide. Okay, this is related to it is named as I-Struct-E NatCon 2024, to be held on 8th to 10th November 2014 at Delhi, with the support of different academic and the research organizations. We have planned to organize this conference. Basically, the conference is of, you can show the themes, Vikas. The main themes around which the conference is organized are related to the global innovations in structural engineering, sustainability and built environment, which we all structural engineers feel that not our cup of tea or not our subject, but it is very well into our domain. And then the latest upcoming AI and ML application in structural engineering. So we could see Professor Sudhir Kumar Viral, who would be the keynote speaker for that. And then the fourth sub-theme is the structural resilience, the vision for the future. And very important, related to all our structures existing and the upcoming structures, is the health monitoring of these structures, the forensic structural engineering and the health monitoring. Okay. Not but not least, the advances in the materials. Okay, materials also do play a very important role in our structural design, etc. So we also catered a session for the advances in construction materials. So request all the participants to kindly submit the abstract, okay, and participate in this conference so as to make the conference a huge success. Okay, the abstract timeline is open for you. Okay, so you can also submit the abstract for the same. These are the important deadlines which is flashed on the screen. So you can submit your abstract by 30th June and then full paper by 31st August, so that you can present your paper during the session. So for the students of the academic institution, there is a discounted registration fees, so they can avail this facility and attend the conference. Now, coming to the business of the day. The webinar on post-install Anchorage to concrete. Today we have the well-known persons as a speaker and the panelist in this field, Mr. Shaunak Mitra, who is heading the quotes and approvals related to the fastening at Hilti India Private Limited. About Shaunak, he is graduation and post-graduation from Jadavpur University, specialized in structural retrofitting. He has a vast experience related to retrofitting and anchorages, working in Hilti, and also as a design engineer, okay, for around 4 years at Datur and Co Private Limited. Okay. he has a yeah, as I was speaking, that he has a vast experience, okay, related to install connection technology, passive fire protection, modification and retrofitting of major building and infrastructure projects, okay. And he's into several BIS and IRC committees, very actively involved in developing the codes and associated with professional bodies. And he's a very key member at I-Struct-E too, and also with IEI, ICI, IAPC, etc. Okay, and he also have an additional responsibility being a guest faculty at Jadavpur University. It's a good thing that an industry person doing an academic thing at this age. Very, very, very good, Shaunak.
Thank you.
So the platform is yours, Shaunak, now. So please take out the platform and provide the insights to us about how these anchorages play an important role, post-install anchorages especially for our structural engineers. Why structural engineers need to know about these post-installed anchorages, the guidelines, the design aspects, etc. So over to you, Shaunak.
Thank you so much, ma'am. And maybe Vikas ji, if you can confirm that the screen is visible.
Yes, visible.
All right, perfect. So thank you so much, ma'am, for setting the context, and a very good afternoon to everyone. First of all, I would like to thank I-Struct-E for at least giving the platform to deliberate on this important topic and this draft Indian code, which is currently in wide circulation. I expect over the next 45 to 50 minutes, I would be able to bring decent clarity on the expectations from the code and what it entails for all the structural engineers going forward, and how it is also going to contribute to maintain or ensure a safe design for all of us. However, the discussion cannot start without really thanking Bureau of Indian Standards. I mean, it has been their continuous effort to really improve and elevate the safety standards of the country, and they have always been leading the way for industry transformation. So huge effort taken up by them, and I think this is one of the results of that huge effort, and many more to come. So with this, I move on to the topic for the day, which is post-installed anchorage to concrete, and the draft standard which is in circulation. So first, we let's understand the different applications and how this is relevant to us, right? So whenever we move around in the construction industry, we will find that it is full of fastenings, applications that connect steel to concrete. Now you move around your building and you will see a lot of applications like fixing of mezzanines, the tower crane fixings, the cranes. If we are talking about building retrofits or strengthening, then maybe steel plate jacketing, providing seismic bracings, non-structural utility support systems, your building facades which include glazings, that include also your dry stone cladding. If you want to fix a canopy, you have your elevator guide rails, the divider beams, the escalator supports. These are just a few within a building segment. Now you go to the infrastructure side of it, then applications like walkway fixing, the light pole fixings, the track signals. You go to metro stations or airports, the utility systems, they again occupy a huge part of it, right? Then for tunnel underground structures, the fixing of strut trailers. For metros, we have the TBMs working throughout the country. Then different applications relevant to the TBMs as well. You get into a tunnel stretch and you see so many applications which include the platform fixings. These can be the handrail fixings, the signal cables, the lighting cables, the tunnel ventilation fans, the OCS fixings. I mean, I could just name a few, but the honestly, the overall application stretch is huge. The beauty of this post install fastenings is they really render a lot of flexibility during the construction phase. Now that you don't need to plan everything in advance, it also gives a I would say it really speeds up the construction, where you can do your concreting at the stretch, and then the different utilities or different systems which come into picture, they can be taken up at a later stage. And obviously they also, if properly designed, they also don't compromise on the structural integrity, which ensures that we achieve the same performance as a casting. So that's where post installed has really become a go to solution for many of us. uh, Now, having said that, this system has also been in existence for the last 2 decades or so in India. And if we have to answer a question that if we are already always doing the proper design of anchors for all post install connections, maybe the answer would fall somewhere between a maybe and a no. Yes, while we are doing a structural design or connection design for all the critical heavy duty applications, for the non structural applications, or for the medium to light duty applications, we are somewhere still going by a rule of thumb or prior experience. And obviously, in absence of a national standard, we also have many a time relied on the manufacturer data, and somewhere the responsibility has also rested with them. So this has been a practice, a reality for us over the last few years, and we have also seen some random engineering judgments, and this has stemmed because of lack of adequate information, which includes using a single anchor load table of any manufacturer, unnecessarily increasing or the load or applying additional safety factors, using an anchor without actually knowing that is that anchor fit for that application, does it actually pre-qualify to the requirement. So these questions have always remained a little bit unanswered, and that's where I say the practices have cannot be termed as the best practices of the industry where we stand currently. But yes, the effort by BIS, I think this draft Indian standard on post installed anchorage for sure would really address this apparent gap in the industry, and this I think is a welcome move. Now, what this code talks about is it has primarily three parts as of now. First is the design of anchorages. The next two parts basically talk about the testing and assessment, one about the adhesive anchors, the other about the mechanical anchors. And this testing and assessment primarily ensures that whatever anchors are being used for an application do qualify all the basic test protocols, and they can be used in all different adverse environments. So that's the pre-qualification which is defined in the other two documents. We'll walk you through all the codes in subsequent slides, but if we start discussing on the design part of it, so first comes the scope. So this is basically dealing with the design of post-installed mechanical and post-installed adhesive anchors embedded in concrete. Now the concrete is in conformity with IS 456 and IS 1343. The set of anchors which can be used, they have to be essentially tested and assessed according to the testing protocol which have been given in the other two documents. We'll cover the test protocols subsequently, but if I have to really recommend an anchor, I also have to ensure as a manufacturer that I qualify those test protocols. And with respect to the load requirements, it covers the static, the quasi-static, and the earthquake loads. What is out of scope of this document is casting anchors. I mean, we have a lot of clarity and understanding on casting anchors. There are design guidelines, so this has been kept out of it. Whereas anchors in plastic hinges are also not covered because they are generally not encouraged for post-installed connections. With respect to loads, yes, we are restricting in static, quasi-static, and earthquake, and therefore the requirement of fatigue, fire, and blast loads have been kept out of it. Obviously, we can always refer to specialist literature when such cases come up, and maybe going forward, we can also develop the standard subsequent to this design requirements. That's broadly the scope. Now we move on to a few important definitions, and maybe the definitions which you see on the slide will not be exactly in the same sequence as they appear in the code, but they appear in the sequence of relevance as per the presentation requirement. So first is defining a post-installed anchor, and this is nothing but an anchor which is installed into a cured and hardened concrete. It is meant to transfer a load, and how it transfers a load is basically through either friction, a mechanical interlocking, bonding, or a combination of all these. Now, post-installed anchors, when we talk about friction, so in this case, when an anchor is transferring through friction, the tension load is transferred to the base material by the frictional force that is built up by the anchor expansion. Right. When it comes to mechanical interlock, so this in this case, basically an undercutting profile is created during the drilling or the setting operation, and that's where the anchor transfers all the load in a manner, I would say, which is similar to a cast in headed stud. That's a more or less a similar working principle. And third is a bonding, which is applicable to post install adhesive anchors, where the mortar creates a bonding between the anchor element and the base material. Second, what we need to understand is the different types of anchors, primarily the mechanical anchors and the adhesive anchors. So I think all of you who are already using the different post install anchors are very familiar with this. And these are basically classified as displacement control expansion anchors, concrete screws, torque control expansion anchors, undercut anchors, when we talk about the mechanical side of it. When we talk about the adhesive type, these can be regular adhesive injection anchors or capsule anchors, or even torque control as adhesive anchors. Now, if you want to really understand the detail of it, there is a dedicated section within the code which talks about their description. It's pretty descriptive and how they work. So I think you can always refer to that. But broadly classifying, I think these are the types of anchors which are majorly used. There are a few important definitions which we have to understand. Is first is here the annular gap. Just give me a minute. Sorry for that. Annular gap. So whenever an anchor is installed in a concrete, what happens is there is a gap which stays, because majorly for adhesive anchors and even for some mechanical anchors, the drill hole is not exactly the diameter of the anchor. So what happens is this gap stays, and that gap is called the annular gap. You can see that in figure 1, what we mean by an annular gap. The second case, or the second definition, which is very significant here, is the hole clearance. And this hole clearance now is on the base plate. So that's the gap on the base plate between the anchor and the plate. So the diameter of the base plate, diameter of hole in the base plate, is always more than the diameter of the anchor. And there is an allowable limit which is set for this. We will discuss in another slide on this. But this is a very important topic when it comes to load transfer. Embedment depth is a third important definition, and you see again two parts to it. So effective embedment depth is the concern for all the structural designs, because that is the depth which actually transfer the forces. So whatever designs we are doing, so we are only concerned with the effective embedment depth, which is giving the resistance. Now, nominal embedment depth is when we are just drilling and putting the anchor. It is the depth at which the bottom of the anchor rests. And generally, the effective embedment depth is a little less than that, because you also torque and the anchor comes out a little when it achieves its effective embedment depth. So these are the few important things which we have to be a little mindful. Fourth is base material. I mean, this is the material where a post-installed anchor is installed, and for the scope of the standard, it's limited to cast in situ concrete and precast concrete. Now, when we talk about concrete as a base material, obviously we understand there are different grades, and that has to be as per IS 456 or IS 134C. But there is also a requirement that my concrete member is strong enough to transfer the load, because eventually that's the area where the entire load is getting transferred. And that also calls for a minimum thickness requirement, right? So the minimum thickness which we need to provide for mechanical anchors is twice of effective embedment depth, but it should not be less than 120 millimeters. When we talk about post-installed adhesive anchors, it shall be at least H effective, which is the effective embedment depth plus delta D, where delta D is a greater of 2 times diameter or 30 millimeter, I mean, whichever is larger. But eventually it should not also be less than 100 millimeters as a total. So that is a prime requirement, and this is very significant from the perspective that if I'm putting an anchor or if I'm drilling a hole, it should not damage my concrete. So that splitting failure has to be taken care of through this thickness. And when we assume a concrete for designing, ideally it should be assumed as crack concrete for all design purposes. I mean, there are all practicing engineers who are, I think they're in the call, or students who are also working on this. So very common definition of crack concrete is when we are following the limit state method of design. And here the definition has been kept as a concrete where there is a probability of formation of cracks after installation of anchors, or we are expecting a significant expansion of existing cracks during the service life. Now, I mean, the way we are detailing or designing the structures, obviously the soffit of a beam or a slab is no longer the only tension force. In case of even gravity loads, and then we talk about horizontal forces like earthquake and wind, then the members are also stressed in tension even in the top upper side of it, specifically if I talk about beams. So wherever a tension force is developed, obviously that comes in a develops a crack, tendency to develop a flexure crack, and then we have also in case of shear a diagonal crack which can also pass through. So keeping in mind this, the recommendation is to assume a crack concrete, and if uncracked concrete has to be assumed, then certain justifications or calculations have also to be provided as a backup. I will explain the significance of the term and why we are talking so much on crack concrete in one of the failure modes. So I request you to be uh, to just bear with me for a few minutes. Next is the effect of edge distance and spacing. Now we have to be a little mindful that our anchors don't behave in isolation, and neither do we always have the flexibility to have a huge concrete all around that we input in our anchors, and they are doing very good. So more often than not we will be doing it on existing structures. In fact, every time we will be doing it on existing structures, and more often than not we will also be restricted by the dimensions, and we cannot do anything about it. So that's where the minimum edge distance or the minimum spacing becomes critical, because this is the spacing that has to be mandatorily provided, or this is the edge distance that has to be mandatorily provided. That it can differ from anchor to anchor and manufacturer to manufacturer, but this has to be provided when a certain type of anchor is being used. You can get the data from the respective manufacturer's recommendation, but anything less than that will damage the concrete. So this has to be ensured. With respect to the critical definition of critical edge distance, so in this case we are having a sufficient edge distance which allows the concrete cone to effectively form, and there is no reduction in the capacity. Similarly, for critical spacing, again we have sufficient spacing between the anchors, and again there is no reduction in the capacity. But in case it is the best scenario to have situation to have if we are able to provide the critical spacing and critical edge distance. But practically when we are limited by the dimensions, we will land somewhere between the minimum and the critical, and that's why understanding this definitions and how they are impacting becomes all the more relevant. The design limit is not only with respect to the concrete dimensions, but we also have to maintain a minimum diameter of the anchor, which is 6 millimeters as per this. And definitely there is a minimum requirement of embedment depth that has to be provided. For mechanical anchors, it has been kept as a minimum of 6 times the diameter, or 40 millimeters, and whichever is more. And obviously, in certain cases, there is a flexibility till 30 millimeters for statically indeterminate non-structural elements. For adhesive anchors, it's dependent on the diameter again. Like for 10 diameters and less, it is minimum 60, and then we go as we go higher up, the value changes. The maximum diameter which is to be considered for design is 20 times, and if anything is in excess of that, we ignore the effect of excess. So 20 is where we fix the maximum contribution. Third is the clearance of holes in the base plate, and that's where we also spoke about the hole clearance earlier. So here also we have fixed there is also a limitation that allowable or acceptable value. So for diameters less than 10, it's like we there is an allowance of +1. For 10 to 24, it's again +2, and then above 24 we can allow +3. And how this is important and why this is so relevant is what I will just cover in the next slide. Now, when we talk about the overall limitations, the most common types of layout which are generally observed is up to 9, and that's where the code has been restricted to use anchors up to 9. If there are any additional requirements, I think engineering judgments can be adopted basis the guidance of the code. Right? We stick to the guidelines of the code and go for engineering judgment. Now, in case of tension, there is no problem. So tension, any case, direct tension, all anchors will take up the load. But the problem of this hole clearance and fixture clearance is when we are talking about the shear load. So if we just there can be two situations. Number one, uh, which is we maintain the clearance in the base plate, hole clearance in the base plate. Number two, there is no hole clearance, which means it is filled up by some appropriate mortar, adhesive, or grouts. When there is a hole clearance, that is, there is a gap, there can be the worst situation where only the first row of anchor is effective and they are transferring the load. So in such cases where the shear load is actually acting perpendicular to the edge, then the design has to be considered for specifically for concrete edge breakout, assuming that the only the front row of anchor is stressed. Whereas if the gap is not there or if it is filled up, then in case of shear perpendicular to the edge, all the anchors can contribute to the load transfer mechanism. Now this is very important because if we are designing considering the effect of all anchors, considering that there will be no hole clearance, we also need to somewhere be specific in our recommendation that this has to be done, and eventually this has to be executed at job site. Otherwise what will happen is you design considering no hole clearance, but you end up with a hole clearance, and then there is a little bit of a problem with the design to execution translation, and safety becomes a question mark. In addition, there can also be cases where there are torsional loads or there are inclined shear forces. In that case, what will happen is there again will be the component. So the component which is parallel to the edge, then again we can take the contribution of all anchors. And in case the components are perpendicular to the edge, the earlier principle follows. That is, if the holes are filled up, all the anchors are able to contribute to the vertical to the component perpendicular to the edge. If the holes are not filled up, then again the first row of anchor are effective in load transfer. So this is a little important when we consider the overall resistance of the system, and that's where I think we spend a little more time here, and we also try to explain this with different cases in the annexure. We'll come to that. There can be again a situation that a fifth case is where there is a slotted hole for the first row of anchor, and that's where the entire shear load is taken up by the back rows when it is perpendicular to the edge. This specifically when the holes are being filled up, the how we consider the load distribution is highlighted in the annexures. So if you see, this is the first case where there is a simple shear load acting perpendicular to the edge. In this case, what we have to do is we have to first check for the crack plane one, considering half of the load. Now I say half of the load because we are talking about four anchors. If there are three basically three rows, it will be v by 3 to then the second row will be 2v by 3, and so on. When we check for the crack plane 2, then we have to consider the whole shear load which has to be resisted by the system. The second case is there is a torsion. Now the components will not exactly be the same as first one. There will be components which are away from the edge and we don't consider them. uh, and in this case we consider the again the crack plane 1 for the forces which are effective there, and then the crack plane 2 for the whole of forces. Now in this case we have to check for both the horizontal component and the vertical component. I mean the component which is parallel to the edge and the component which is perpendicular to the edge, and the resultant has to suffice the safety requirements. There can be two more cases wherein there is a shear force acting parallel to the edge in addition to the torsion, and there can be a case where the shear force is acting perpendicular to the edge in addition to torsion, and there also we have to apply similar logics or algorithms to calculate the effective forces for which the system has to be checked for. So I think if we are able to understand the load transfer for specifically for cases of hole filling, then we would be good in that case. And obviously, in case there is no hole filling, these discussions don't happen. They just convert to the anchors in the first row. Now, the design philosophy or the design concept is it simply follows the limit state method, that fundamentally my design resistance has to be greater than my design load or my factored load. That is the simple understanding of the guideline. Now, when we talk about an anchor, there can be multiple, I would say, load cases which can happen on the base plate, like direct tension, compression, shear force in one direction or in both direction, bending one direction, both direction, torsion. But eventually, when the loads are converted to the anchors, these are basically tension and shear loads. So when we check for tension, we have to check for two components. One is the steel, second is the concrete. When we check for steel, it primarily the failure can occur if the number of anchors are not sufficient, if the diameter is less, or the steel grade is not sufficient. And how we check that is basically you will get this capacity of a single anchor for from all the reports of any manufacturer, right? They come up with the capacities of individual anchors for each type of anchor. You can have that. If it is not there, then we can also use our fundamental engineering concept, which is the stressed area, not the full area, but the stressed area of steel multiplied by the ultimate tensile load, tensile stress, and then we divide it by the partial safety factor to get to the design load, and then we compare it with the external load. With respect to concrete, there can be three situations when the anchor can be pulled out. There is a concrete cone which has developed, and there is a splitting failure. So I again take you to the concept of pull out. It occurs primarily when the bond between the concrete and the anchor has failed. And in case of adhesive anchors, it can also happen that there is a slippage happening either at the interface of the concrete or and the adhesive, or at the interface between the adhesive and the anchor element. So that's how we see a pull out failure happening. And how we again consider the values is the this should ideally be available from the again the report assessment report provided by the respective anchor manufacturer. For mechanical anchors generally, and for adhesive anchors, it's a combination of different things. Like we also have to consider the embedment depth, we have to consider the diameter, we have to consider the bond strength, and also if it's a sustained loading, that factor should also come into picture. And that's where we come to the design resistance for a single anchor, which is this n naught rkp. And then as we also discussed that anchors don't behave in isolation, so what is the multiplier that we can actually achieve out of that anchor group can be taken up from this ratio of apn by a naught pn, where apn a naught pn is the ideal anchor, ideal area on the surface, projected concrete area on the surface, and a naught pn is apn is the actual area limited by the overlapping effect of adjacent anchors and concrete dimensions, right? And then there are other factors considering the existing reinforcements, then considering the effect of eccentricities, which also contribute to the eventual design resistance. Third is a cone failure. I mean, this is a very simple failure which requires basically the increase in volume of the engaged concrete cone. So if we are placing the anchors very close to the edge or very close to each other, then these kind of failures are for sure likely to happen. Again, how do we calculate is like n naught rkc we define. That's the capacity of a single anchor, influenced by obviously now the embedment depth and the concrete grade. And then we have the influence of adjacent anchors and influence of concrete edges by this multiplying factors. So the principally it's same as pull out, just that now we are focused more on the concrete cone capacity, which is a factor of your effective depth, embedment depth, and the grade of concrete. Now, just before I go on to this concrete pull cone failure, move further ahead, I just want to highlight this part, this tau RK, or the bond strength or the pull out. Generally, when the anchors are tested, and this is available in all multiple literatures globally. So when we consider an uncracked concrete, we have certain capacity. When we consider a cracked concrete, there is the anchor is having a different capacity. Now this resistance or capacity in a cracked concrete generally is like 30%, 25 to 30% lesser. The reason is, I mean, whenever we are considering an uncracked concrete for design, and if cracks are likely to develop during the service life, because we are considering also limit state, then there is a problem with the system stability in such cases. And there are examples or works done by Lodze and then Professor Eiliga and other experts globally that also states that whenever there is a crack and if there is an anchor, there is a high likelihood that these cracks will also move through the anchor locations, and that's where considering an uncracked concrete capacity can also be a little detrimental. Last is the splitting failure, and this happens in very thin, low reinforced members or very high embedment depth of anchors. So that's where we also have to control, and that is the reason we had already discussed earlier about the minimum requirement of concrete member. And there are certain ways that this can be restricted. If we are able to check the pull out and cone for crack concrete, and then we also have reinforcements that restrict the crack width to 0.3 millimeters. In such cases, we can still avoid discussing the splitting failure, because that will be by default taken care of. Now, whatever we have, the smallest shall govern the design resistance. And then we come to a tension capacity. Then we again go to shear load. There again, there are two components. One is a steel, one is a concrete. For steel, there can be two situations, which is a pure shear and a bending shear. So pure shear is where my base plate is kind of flushing with the concrete surface, and the bending shear is where there is a good standoff. We see a lot in case of light pole fixings, and again this failure can occur if the diameter or the grade of steel is not sufficient. We get the independent or the single anchor capacities from the assessment reports, and for standoffs we have to additionally check for the bending resistance of the anchor. That is an additional check, and this is also covered in the steel failure section for shear within the code. We move on to the concrete part. So concrete part again has two things to be checked. One is the pry out and one is the edge. So what is pry out is when we have a very shallow embedment depth, and there can be a failure which happens further away from the edge. So this can be taken care of if we are able to achieve the required cone capacity, and we are able to achieve the also the pull out capacity in case of adhesive anchors, and we can compare that and ensure that pry out does not happen. It can be improved by increasing the embedment depth, so that we are also able to have a greater volume around it, greater volume of concrete around it. The last failure mode is basically concrete edge, and where we have a very high shear or where my anchor is very close to the edge, we can observe these kind of failures to happen. And this is taken care of by the resistance of a single anchor, which is again dependent on my grade of concrete, which is dependent on my embedment depth, which is dependent on my diameter, and we can calculate that individual capacity from the clauses of the standard. And then we have to also take into consideration the single anchor effect, and we have to take into consideration the group effect to arrive at the final design resistance. And whatever is list has to be taken into consideration. And finally, there is one more check which has to be done if we have both tension and shear forces acting, and that's where we have to do an interaction check, where the combined behavior should be less than 1.2 for steel and has to be less than 1 for other concrete driven failure modes. Right, this is with respect to the static part of it. uh, the question is, we are also living in a highly seismic prone country, right? And then we see a lot of standards are getting developed, a lot of revamping happen in terms of our IS 1893. We also see uh, the ductile detailing of steel structures is already rolled out. The standard for 13920 is again in wide circulation over the last few days. So a lot of changes are happening with respect to the overall structural requirements. So the question to address is, does the requirement remain same for anchors when we talk about static and seismic? Let's understand this. So the basic design requirement here does not change. Whatever checks we have done will continue to do, but there are few things that we have to additionally take into consideration. Number one, as a prerequisite, now in static condition, what we were doing is, as a prerequisite, we are evaluating the performance when the anchor is in the correct location. That is a prerequisite. Now when we talk about seismic, that prerequisite of seismic consideration has to be taken during this assessment. That which means my anchor should be tested against those required seismic test regimes. Also, we have to take appropriate measures to ensure that the nut does not come off during the seismic event. Again, that concept of gap, the whole clearance which we have discussed in the shear, it has again a very significant role to play in case of seismic. So if there is a gap which is left, In case of earthquake, there will be this hammering effect between the plate and the anchor, and that's where it will call for a further reduction based on this alpha gap. And the general recommendation still stays that we don't leave this gap, so that there is no reduction, and at the same time we ensure that equal distribution is happening within the anchors. Now, how do we calculate the loads on the base plate? Very simple. IS 1893. The design forces as per IS 1893 is the basis for the base plate loads, and that has to be calculated using the, I mean, that load has to be carried by the anchors. For non-structural components, I think it is also important that we put a little bit of an emphasis, because non-structural components, yes, they are not the most critical structural applications, but they are not very non-critical either. They occupy a huge portion of the building structures, or the cost, and if there are failures, these can have even bigger repercussions. So reference to 1893 can be made. There are also this code of IS 16700 for tall structures, tall concrete buildings, which can be made for determining the forces on the non-structural elements, and then the anchor design follows the normal principle. How we design the anchors, it can be done using three approaches. First is the capacity, wherein we design for the capacity of the system. The capacity of the system is either the capacity of the member which is attached, which is the structural steel member, the ISMC, ISMB, anything, or the capacity of the base plate. Either of it has to yield, and that is the capacity that we are designing the anchor also for. Second is we are designing and considering an elastic behavior, which means that we are designing for the actual load condition and assuming an elastic behavior of the anchor as well as the structure and the fixity. So we don't consider an yield mechanism there. So that's the ideal case. And the third is when we consider a ductile behavior of the anchor, and the requirement here is that the anchor should fail in steel even before it fails in concrete. So this may not give the best of results when we talk about different applications, but obviously it depends on the decision of the structural engineers, what you want to follow. But the general recommendation is to still go by the capacity and the elastic designs for majority of the applications. And what we do here is the design checks, again similar design checks, just like we did for static. We do it for tension, we do it for shear, and then we consider this alpha gap if there is a gap. If there is no gap, then we don't have any reduction factors. And there is another factor which you can see is alpha seismic. So alpha seismic is basically taking into consideration the effect of large cracks, and if there is a scatter of load displacement behavior also, that is also taken care of here. Now the values to be adopted are given in the code. There are dedicated tables where from which we can easily pick the values and plug it in our design calculation, so that should not be a problem. And obviously conceptually the minimum strength governs for each load direction, and when there are combination of tension and shear, we also have to go with a interaction check. So design wise it does not change. There are some additional considerations for earthquake as an effect. This was more about the design part of it. Let me now take you to the testing and assessment, which are the other two documents. And here I will cover both the documents taken together, because the scope is not different. Maybe they are talking about different types of anchors, so that's where maybe the test protocols will be different, but the scope and other aspects still remain the same. So first is it's talking about the testing and assessment of post-installed anchors. One is talking about the mechanical anchors, one is talking about the adhesive anchors. The testing is done under static, quasi-static, and earthquake loads, exactly similar to the requirement of our design standard. The assessment is done to check the suitability for use, and when we have to do the designs, we also need the characteristic values. So those characteristic values are to be obtained as a result of these assessments and captured in the reports, assessment reports. Now this entire thing has to be carried out in an independent third party laboratory, and evaluations have to be done by competent authorities, and then the reports can be issued. But just to clear the air, this is the whole and sole responsibility of the manufacturer. It is not a responsibility of the consultant, the contractor, the client, the owner. No one is responsible for this. It is a responsibility of the manufacturer only to ensure that whatever anchors they are providing, they comply to the test requirements of this Indian standard. And what is tested and how it is tested is basically we this test protocol is defined for different conditions. The one is ideal conditions or the admissible service loads tests, and there can be non-ideal conditions which are the suitability tests. And we'll give you some examples. The sensitivity to drill bit. So when someone is installing an anchor using a brand new drill bit, and someone is installing an anchor with a worn out drill bit, maybe which has been used for multiple holes, and for example over a period of 2 3 4 months, so there will obviously be the difference in the diameter of the hole which is cut. Maybe not understood by a naked eye, but yes, there will be minute differences. Also in terms of the surface that is created within, right? The installation safety factors which have to be checked for, checking for crack cycles, checking for repeated loads, checking for cyclic loads, right? And then for mechanical anchors which are governed by torque, which are majorly torque control, then what happens if there is a inadequate torque which is provided? What is the robustness against this? What happens if the anchor, an adhesive anchor, is installed in a hole which is not properly cleaned, or it is water filled? What is the resistance in that case? What if an anchor, adhesive anchor, is installed in a vertically upward direction, overhead application, or in a horizontal application, or vertically downward? So how all these things are considered? In case of an adhesive anchor, again, there can be an effect when there is a freeze and thaw, extreme changes of temperature, right? Minimum temperature, working temperature. So all these things are generally these are actually captured in this test protocols. And that's how the assessment reports have to be generated once an anchor qualifies all these test regimes. Now this is not a project specific report. This is a product specific report, and the applicability is till the period the certificate holds goods. So there is always a validity of the certificate, and till that I think the certificate can be widely used and not specific to project. How this assessment report generally should look like is an example has also been provided. Like for example, it talks about different criteria. I think the font size is a little less for many. So description of the product has to be there, the assumptions for assessment, the performance category, the general drawings, product drawings, the nomenclatures, the material information, installation part, everything has to be specifically spelled out here. And then the load parameters of in terms of tension, shear, the embedment depth, the temperature effect if it's an adhesive anchor, if the grade of concrete is not exactly the same, then how do we accommodate that? All these things have been calculated for static as well as for seismic conditions. Yes, currently we do have isolated research work in the country, but it's a little limited. But I think with the standard also, we will also make a good progress and have a competent body to issue such certificates. Then, but it definitely will take time, but we for sure have a very bright future in this. Till the time, I think it's a responsibility of the owner of the project or the project authority to accept anchors only if they find the anchors comply to the assessment reports by a body. And that assessment report should actually be based on the minimum test requirements as per this Indian standards. If it is more, then very good, more stringent is always welcome, but then this minimum test requirement has to be met when we check an assessment report. And a very common example is a European technical assessment, which is also used in India for different products, not only just for anchors, but for different products. And that is like based out of the European assessment document. So that's a common example. If I have to summarize broadly, so post-installed anchors are extensively used in the construction industry, both for heavy duty as well as for medium to light duty structural applications. Uh, Safety is of paramount importance for all of us. And this safety is basically a trifecta of three components. One is a product assessment. We know that what product we are using, it has already qualified for a particular basic performance requirement. We do a design for it, and then we do a proper installation at job site. The encouragement is to avoid a rule of thumb and perform and accept only a proper design for every application. Yes, we are doing designs for a lot of cases, but somewhere we still don't do this. And the encouragement with this Indian standard is, let's also elevate and transition into a design approach. And finally, when we accept an anchor, we also have to be careful that whatever is being provided also comply to or adhere to a minimum performance requirement. So that's the key takeaway, I think, for from the three draft standards which are in wide circulation. I thank you for a patient listening, and over to Vishalakshmi ma'am for further discussion. Thank you so much.
Yeah, thank you, Shaunak. Thank you very much. After listening to this presentation, I feel that you have imbibed very good teaching skills. That part-time or else that job at the Adapur University is giving you a lot of experience into the teaching skills. You have very meticulously planned your presentation and synchronize the presentation the way it went on, first describing the different description of about the anchors, etc., and what are the codal provisions, then how to design, what are the loads and the failure mechanisms of each and every anchor, how to design, how to test. Wow, very
Thank
nicely articulated presentation, Shaunak.
thank you.
I think just by listening to your presentation, we would definitely have a good understanding about how these post-installed anchor works. Very nice.
Thank you so much.
So now, participants, along with Shaunak, who is an expert in the post-installed Anchorage domain, we do have other experts as a panel members. So let me have the privilege to introduce you to the other panelists. Um, the panelists include Amandeep Garg, who is the founding and managing director of Creative Design Consultants and Engineers Private Limited. He has a vast experience of more than 25 years in multifaceted domains, especially in construction, management, planning, coordination, structural design, and other things. Okay. And the other panelist is Kamalika Kundu, who is a technical expert on post-install fastenings and fire stopping. She's currently working as regional codes and approval manager at Hilti Asia Pacific Limited, located in Singapore. And her research interests include concrete post-install anchors, post-install rebar, and the seismic related activities about these. Now, I would like to rope in our panelists and ask them their first comments about the draft code and give more insights into how these draft code could bridge the gap between the practicing engineers and their understanding. Yeah, Aman, I'll go to you first.
Yeah. Thank you, Professor Vishalakshi. Actually, it was a wonderful presentation by Mr. Shaunak Mitra. And I must say that it is the need of the country to have a special standard on these anchorage systems. Earlier, over the days when people used to go for only the in situ anchor systems, but now we need more flexibility, and most of the times when we have to go for some kind of retrofitting or some kind of vertical horizontal expansions and many other infrastructure projects, this post anchorage systems are not are the only options we structure engineers have. Now, coming back to the concept level, when we started this standard formulation activity around a decade back, that the country needs this standard, though this testing facility for this kind of systems is not very well developed in our country. But one step has been taken that the standard is being made not only about the design, but with the testing systems also. The first part, the design aspect of the post anchorage system is now available as a wide circulation draft. So all the participants, I would request that they should see this wide circulation draft. It is still not approved as a final draft. It is not a Gazette notified standard at this moment, but it is open to your comments and suggestions. So all the listeners and their friends can see this document through the BIS website. They can see the practicality. If they have any doubt about any area, they can still mention that this part of the standard is not very clear. Or if they have some suggestions for the betterment of the standard, they can still give some suggestions or comments. And that will be again taken care by the technical committee of BIS. And based on all of your inputs, this standard would be verified or certified or maybe later on gazette notified. One thing more I would like to add to this discussion is that this is the beginning, because at this moment we have many challenges. First aspect was the design, then selection of the appropriate anchor for the need, which should be like tested, verified anchor, which can be utilized in our projects. And the third aspect is the final quality control system. Like if our anchor is good in laboratory, if it is tested good, if it has been designed good, but then later on, if it is used, then the workmanship also plays a very important role. So how would we ensure about the final workmanship also, so that there is no gap between the final delivery and this starting step of the design. So we are trying to cover everything. So there will be series of standards on this, and this is the first standard, which is a wide circulation draft, which is for the design. All of you, I would request again that please see it and give your best suggestions for this. With this, I request Kamalika ji to add her views on this, because we both were the panel members for the preparation of this standard. Shonik also joined later, but Kamalika is the person who initiated this standard. So now I will request Kamalika to take over.
Thank you, Amandeep sir. Firstly, I would like to thank I-Struct-E for taking this initiative to make the community aware of this draft in wide circulation. And then I would also like to thank Shonak for the excellent presentation. I would second what Visalakshmi ma'am said, that really his teaching skills have improved, his presentation skills have further improved. I think, I hope many people in the audience would agree that whatever he was presenting, at least you were able to grasp a part of it. The topic for today, the post-install anchor design, I think is a very welcome move by BIS. As Amandeep sir said, it has been a decade in the making. And there were a lot of requests by the industry, and BIS took that request seriously. And it takes time. It takes time to develop standards on topics that are new, to be thorough and all of that. And I think the core reason for that, in the industry is one of the slides that Shonak had flashed, the all sorts of practices that are happening in industry, the load tables, the thumb rules. So one of the idea behind this standard is also to encourage the designers to move more and more towards design anchors instead of all those practices. And hopefully the standard would help move towards that. Amandeep sir has already talked about all the aspects, so maybe I will only second that. A very good post-install connection to make sure it works the way it's meant to. You need to first design properly, and for designing, you need to able to select the anchor that meets your application needs and requirements. Let it be specific temperature ranges, concrete grades, environmental condition, exposure conditions, whatever is the need. You select the anchor, then design it, and then install it correctly by a person who is trained to do so, and then it's documented properly so that future maintenance, if necessary, can be done carried out properly. I would also encourage the participants to please review the standard, the draft standard, give their feedback, and when hopefully it's finally published, also make good use of the standard to design the connections. So that would be my simple message. Back to you, Visalakshmi ma'am.
Yeah, thank you. And thank you, Aman and Kamalika, for the initial comments on the draft code. I think we'll take up some questions. Okay. Any one of you can answer the questions. Okay. So the main question is, the corrosion related aspects are not being covered, whatever the Shonak has presented. So have the corrosion of the anchor itself is taken care at some of the other point, and how to look into that aspects of if at all the anchor is being corroded and has lost its strength, then what is the way out? How to
So maybe
deal with that?
I'll go.
Yeah, Shaunak.
So the corrosion basically can be taken care of by the material. So if we are working in a very corrosive environment or a very aggressive environment, the use of stainless steel or hot dipped galvanized anchors can be used. Whereas for normal conditions or indoor applications, maybe a normal 5 micron galvanized or whatever be the industry practices, those are good to suffice. So corrosion can be taken care of by the durability part of it, not maybe through the design aspect.
All right,
Okay.
Sean.
So
Actually, it is a complete system of concrete as well as anchor. So wherever we have any doubt about the corrosive environment, we must take care of the proper anchorage, proper concrete, and if required, as Shaunak said, we can go for stainless steel bars wherever we feel.
yeah. Okay. Because the reason why I'm asking is these anchors are exposed directly to the environment, right? Okay. So, do you need any protective coatings in order to take care of corrosion of these anchorages? Do you suggest, or it's out of scope of the code?
No, which is not part of the scope, but actually any
Okay.
metal which is exposed to the environment need to be protected. The
Protect, yeah.
anchor part which is inside the concrete should be taken
That
care by the good
cared by
quality
the
concrete.
concrete durability,
The
yes. The
part which
one
is
which is
outside the
exposed.
concrete need to be taken care by the suitable methods of some zinc coating or something like that.
Yeah. Yes. The other question that the participants are asking is, because of providing these post-installed anchorages, do the parent concrete reduces its strength? What is the effect on the parent concrete?
Shaunak, you want to answer?
Uh, Maybe there is no significant effect on the parent concrete, because that's the area where this entire load is getting transferred. So if this is having a negative impact on the parent concrete, I would say this technology is not the best technology to be used. So
Yeah.
wherever we are using it, there is no adverse effect. But one thing is, if there are unnecessary holes which are being drilled at the time of installation, those have to be essentially filled up. We cannot leave them as it is. Those
Yeah.
are dangerous.
Yeah, I would like to add here that the spacing of the anchors plays a very important role. And that is why the standard specifies the minimum distances between the anchor holes. Because when there is a load transfer through an anchor into the RCC system, there will be some stress concentration. So there should be some safe spacing for the loads or stresses to be distributed between inside the RCC element. So having anchor just at the edge will be a bad idea.
Yeah.
But anchor in the core should be a good idea. So that is why the code suggests that how the designer should take care of all the critical aspects of the design.
Okay. So one of the participants asked, Shaunak, it's for you, that in one of your slides you mentioned two planes, no? The first plane and the second plane, right? So here he is asking that for the second plane, okay, why are you taking the load as V? Why not it's half of that of the V related to the second plane? Shaunak, are you there? I think
I think he is not well connected, but I would just suggest if you have this kind of query and you have some reference for that it should be V by 2, but not V, you can simply write to BIS and the committee can look into the matter.
Okay. So, Pulkit Velani, I think you can write it to the BIS. Please go through the code and then flag the relevant recommendations or the issues which you have. Okay.
Maybe I can. Okay, I think Shanak is back. So I was about to
Yeah.
answer.
Okay.
Shanak,
Yeah.
are you there?
Kamalika. Yeah. Please carry
Yeah,
on. Go
Kamalika,
ahead.
you go ahead, because I missed out on the question. There was a power cut at my place and the
It's
internet got
it's the
Oh,
disconnected.
second crack plane. Why it's V by sorry, entire V, not V by 2 in your slide. I don't know if you want to show that slide again.
I'll show that, and if you want to answer, I mean, please go ahead. I'll just share the screen.
So basically, we are checking for the two cracked planes, and when it's passing through the second, so basically your first line of defense has failed, right? The first set of anchors. So the entire load we are assuming is being resisted by the anchors in the back row. That's the very simple concept I have to
Okay.
answer.
Okay.
Shanak, if you want to add.
No, all good, all good. That is a
Okay.
simple
Yeah.
explanation.
I think that's a simple, very simply Kamalika had explained it. So the other participant asked that the code talks about factor to account for negative effect of orthogonal reinforcement in basic concrete characteristic strength, computed based on some presumed orthogonal reinforcement. If S shall be specified, can we specify something like that?
The
Is it
question
clear?
is,
Is the question clear or is it incomplete?
I did not get the question. In fact, I'm not able
What
to
is
see the questions also. There's
okay?
some problem.
Okay, so what the participant is asking is the code talks about factor to account for the negative effect of orthogonal reinforcement. Okay, so he is
Hmm.
asking that is basic concrete characteristics computed based on some presumed orthogonal reinforcement? Is the basic characteristics computed based on the presumed orthogonal reinforcement?
Uh,
No,
no,
No.
no,
Okay.
no.
Okay. Then what is the factor which we need to be
So
accounted for the
that
negative
that
effect?
factor basically talks, if I understood which factor this person is referring to, that factor, that RE factor,
Aryan.
refers to the dense reinforcement, especially when you are talking about the shallow embedments. Yeah,
Okay.
that's where you take into account. But in general, for the overall characteristic, it's not.
Okay. Okay. So the other participant asked that will there be any changes of LT tables after implementation of this code?
So that's why I said the maybe this question I take. So now we have to actually move away from the manufacturer tables, because those are ideally for single anchors, and it's not about Hilti, it's about a generic manufacturer tables. So with this code we have to elevate ourselves and get into the design part of it. Let's
Okay.
do away with the table concept.
Okay. So you suggest that now let's not look at the tables which are being provided by the manufacturer, but the designer who is designing should take the responsibilities of looking into the anchorage, the design, etc. Right?
Yes,
Yeah? And doing the respective checks for the safety of the anchorage. Hmm?
right. That is the answer.
Okay. Okay. So the responsibility is now lying on the designer, the
It's
structural
with all of
designer.
us. It is with all of us.
Yeah, that's all. So all the structural designers should know that you should be much more careful. So what about the fire resistance of adhesive material which you use for the adhesive anchors?
So the fire resistance has been kept out of it, and there is a note where we have described all the anchors. There is a note that uh, when we are using adhesive anchors, we have to be very careful about the fire part of it, and that entails a lot of detailed calculation. So specialist literatures can be referred to, and if there is a scope in the future, we for sure can also integrate this in the standard. But as of now, to make life simple, I mean, that has been kept out of it.
And
Yeah,
I
we
would
can't
add to
expect
that
everything
because
into the first draft itself.
I
Yeah,
was about to
some
say that let the draft come out, and I
yes.
think over the time it would evolve
Right,
based on
right. Okay. Definitely it would evolve as it gets matured. Since it's the first draft, let it come first into the market and then we can add it up. Right. Okay. Uh, the other important and a very good question one of the participant is asking is while you test the anchors, okay, you test in the laboratory. Okay. So how the laboratory based concrete is well correlated with that of the concrete which is at the site. So how well you correlate the results in the laboratory as well as the site? What is your suggestion?
Kamalik, you want to take this? Yeah.
So during the testing, we test at different grades of concrete, a lower end and a higher end. And as Shonak was explaining, we test at various suitability conditions, various installation conditions. And after that, from the ultimate load, we determine your characteristic 5% fractile values, and we also apply further safety factors, which is eventually for design. So if I have an ultimate load of, let's say, 20 kilonewton, it might be published as 4 or 5 kilonewton. So that's the kind of safety factor depending on the anchor. So obviously for any product, you can't actually mimic as long as the concrete grade is in a certain range. As long as you ensure the concrete is of good quality, there's no honeycombing and all of that, and it's suitable for anchoring application, and it's within the range of the anchor grades defined in the code, it's good enough, because there are enough safety factors embedded into it. Anything else to add?
It all boils down to how you maintain the quality of the concrete. Yes.
Yes, because
That's
you
main-
won't build a
Exactly.
building and say that it's M25,
Yeah.
but we have M15. So it's the same logic applies here. So
Yes. So the other participant asked that, your design and the testing, whatever you are doing, is that your anchorage is being surrounded by your concrete, correct? What if the anchorage is touching the reinforcement and not the concrete around?
That's
Having
not
thought of?
that's not a problem. So the general recommendation is before drilling, ideally the best way to do it is you should identify the safe drilling locations. So do not we don't want to end up in a situation that for a 4 anchor we end up 8 holes. That's very bad. So first let's identify the right drilling points, then we don't actually encounter those situations. And if an anchor is resting on a reinforcement, I think that's not as bad, so long we have the concrete around it.
That's right. And that is why, as a standard practice, scanning of the surface is required to identify the nearest reinforcement locations. And based on that, safe locations for the anchorages are marked on the concrete surface, and then the anchorages are done.
Okay.
So drilling should not be arbitrary.
Yeah, exactly. First, you have to identify the position where it is required, right? Okay. I think I'm exhausted with the questions, and I think we can wind up. Vikas, what is that next thing I need to do?
No, ma'am. We can close the session if the.
Okay. So let me thank Shaunak. First, thank Shaunak for giving a wonderful presentation where a layman also can understand what he's trying to explain. Very methodologically presented. Okay. Thanks, Shaunak. Thank you so much for making our participants understand about the importance of post-installed anchorage. How does it work? And what does the code is actually trying to give? Okay, thank you so much.
I would like to add that some people have requested for the standard. So the standards may be reached out at Bureau of Indian Standard website, bis.org.in, under the wide circulation section. So one can easily find out the standard under the wide circulation drafts, and you can directly comment over there also, or you can write the email to the Bureau of Indian Standards Civil Engineering Department.
Yeah. And special thanks to our panelists for answering all the questions which have been raised by the participants. Thank you so much for making us aware about the importance of the codal provisions related to the post-install anchorage. Thank you so much.
I would like to thank you, Professor Vishalakshi, for conducting this program very effectively, moderating everywhere in a very presentable manner. I hope everybody enjoyed your way of moderation and presentation. Thank you.
I will second that.
Thank you.
I second.
Thank you. And we'll look forward to the code and see how it can better our structures and lead to a very safer and these structure. Thank you. Thank you so much.
Thank you, everyone.
Thank you, Vikas. Thank you, participants. Thank you so much. See you next.